Hey everyone, so if you've ever peeked at some code, you've definitely seen symbols like the plus sign or maybe some ampersands. Well, those are JavaScript operators. And they're not just decorations. They're the absolute building blocks that make your code actually do things. Today, we're going to break down exactly how they work.
So let's start with a little puzzle. What do these three symbols right here have in common? You've probably seen them around. I mean, one's obviously for math, one kind of looks like a typo with those three equal signs, and the other one, well, what's the connection?
And the answer is they're all operators. That's it. An operator is just a symbol that tells the computer to perform an action. You know, if you think of your variables in your data as the nouns of your code, then operators are the verbs. They are the action words that make stuff happen.
So first up, let's explore why these are truly code's most essential symbols.
We're going to start with the ones you already know, the stuff right out of math class. Let's talk about the operators for doing calculations.
Okay, so the first few here are pretty obvious, right? Addition, subtraction, you get it. But the last two on this list are super powerful in programming. Modulus, that percent sign, gives you the remainder of a division. It's awesome for things like checking if a number is even or odd. And exponentiation, the double asterisk, is just a super clean shortcut for calculating powers.
A lot of the time, you just need to add 1 to a variable. We call that incrementing. But you gotta watch out, because the timing is everything. If you type x++, the code uses the variable's current value, which is 5 in this case, before it adds 1. Then, in the next step, x is now 6. But if we use ++x, it adds 1 first, making x jump to 7, and then it uses that new value. This little difference between use then change and change then use causes so many bugs, so it's a really good one to get straight in your head.
Doing math is useful for sure, but the real magic of programming comes from making decisions. And for a code to make decisions, it has to be able to ask questions. So that brings us to our next set of tools, comparison operators. Now, these operators work a little differently. They don't give you a number back. Instead, they give you a simple Boolean answer, true or false. That's it. Is 5 greater than 3? True. Is 10 less than or equal to 9? False. This simple, two-option answer is the foundation for all decision-making in your code. Okay, pay attention, because this is one of the most important concepts in all of JavaScript. Strict equality, the triple equals, is like a super strict security guard. It checks for the value and the data type. So to the triple equals, the number 5 is absolutely not the same thing as the text character 5. But loose equality, the double equals, is a lot more relaxed. It tries to be helpful by converting the types to see if they can match. And that can cause some seriously confusing bugs.
So here's the golden rule, the one piece of advice that will save you so much pain later on. Always, always, always prefer strict equality. It forces your code to be predictable and stops JavaScript from making weird assumptions for you.
All right, so now we can ask simple true or false questions. But what if we need to ask more complex ones? Like, is this true and is this other thing true? Well, that's where our logical operators come in. They're basically the glue that lets us stick our conditions together.
First up is the AND operator, which we write with 2 ampersands. Think of it as a really tough bouncer at a club. To get it true and get past the gate, every single part of the condition has to be true. If even one part is false, the whole thing is false. The gate stays shut.
The OR operator, on the other hand, is way more chill. You write it with 2 of those vertical pipe symbols. For OR, you only need one of the conditions to be true to open the gate. As long as at least one part of your expression is true, the whole thing becomes true.
Let's look at our real-world example. Say we're coding the logic for a nightclub entrance. The rule is, the user's age must be 18 or over, and they must have an ID. So in our code, the age is 20. Check, that's true. The variable hasID is also set to true. So because the part on the left of the AND is true, and the part on the right is true, the whole thing is true. Access granted.
So we have all these amazing operators. But what happens when you mix them all up in one line of code? Which one gets to go first? It's not a free-for-all. Just like PEMDAS in math, JavaScript has a rulebook for this. It's called operator precedence. Here's a quick peek at that rulebook. You can see that operators at the top of the list, like multiplication, have a higher precedence.
They get evaluated before operators at the bottom, like addition. But the most powerful rule of all is right at the very top, grouping with parentheses. Parentheses let you take control and decide the order no matter what.
Okay, let's put this to the test. Take a look at this. What do you think the result is? Is it 16 because you just go left to right? Or is it something else? Think about it for a sec. The answer is 11. And why is that? It all comes down to precedence. JavaScript sees the multiplication sign and knows it has a higher rank than the addition sign. So it calculates 3 times 2 first to get 6, and then it adds the 5. That order makes all the difference.
Which brings me to the single best piece of advice for dealing with this. When in doubt, just use parentheses. Not only does it guarantee the calculation happens in the order you want, but it makes your code 1,000 times easier to read for anyone else, including you 6 months from now.
So, we filled up our programming toolbox. We have tools for math, tools for making comparisons, and tools for combining logic. The only real question left is, what are you going to build with them? It's your turn!
With just these operators, you can already start solving real problems. You could build something that calculates the area of a circle using multiplication and the exponentiation operator. Or you could write the code to decide if a user is allowed in somewhere by checking if their age is over 18 or if they have special permission.
These operators are your way in, your first real step into the world of creative problem solving that is programming. You can build something real with this. So, what problem are you going to solve first? Thanks for joining this explainer.